Hi, my name is Alain. I'm the founder of Ohmslo, a business that sells open hardware. But our main product is NoCan, a little platform that allows you to create a wired IoT network. So basically, you take a Raspberry Pi, you add this little board on top, and then with that you can control an army of little nodes like this, Arduino-compatible little nodes. And the only thing you need to do that is a cable like this. Pretty simple. So you might ask, why build such a thing? Today when people talk about IoT, they basically make it synonymous with wireless, Wi-Fi, Bluetooth, LoRa, Zigbee. And these things work great in practice. But there is a niche for applications where the wireless approach simply sucks. You may have been to a maker fair seeing people build a nice little project with an ESP32, only to hear that they need to change batteries every week. You may have a project to water your plants automatically in the garden, where a small microcontroller needs to control a valve. Well, that little valve will take a lot of milliamps, and the little battery won't take you very far. Or maybe you're worried that your neighbors, when they start their microwave oven, kind of messes up your network. Well, in any case, there's plenty actually of applications where that little Wi-Fi magic or Bluetooth magic just won't cut it. So we wanted to make a platform to answer this kind of gap, but make it cheap and maker friendly. So this is why we designed the NoCan, and it's based on CAN bus. So you might say, well, why CAN bus? Well, if you want to connect things with a wire, well, you have a lot of choices. To start with, power over Ethernet sounds like the perfect candidate for this kind of application. The thing is, power over Ethernet is expensive. It's bulky, means that you're going to be making boards that are quite big, expensive to manufacture. It's not exactly maker friendly. Of course, it has the great advantages of TCP/IP, but then also that means a bigger microcontroller, a more complex system. So then we can look at traditional approaches like SPI, I2C, UART. These things are basically free with modern microcontrollers, but you will not cover very long distances, at best a few meters. Next we have RS-232, and this is nice, but it's limited to 2 nodes. Its cousin, RS-485, is actually a pretty good candidate here. The only downside is that it's not truly multi-master. What I mean is that typically with RS-485 you need to kind of design a protocol to let each node speak one after the other. You cannot let every node speak at any time they choose. There are hacks around that. You can design protocols that detect collisions and work around it. But then there is an alternative that does that already, and it's called CAN bus. So we designed NoCan platform, the NoCan platform around CAN bus. So to give you a bit more details of how it works, you connect this Raspberry Pi with a hat to this node with just one cable containing 4 wires. One wire is ground, one wire is power, your VCC, your 12, 24 volt typically, and you have 2 wires, CAN low and CAN high, that form a differential pair that makes the communication immune generally to noise. And with that you can cover pretty big distances with one cable that brings you everything. So there's no more battery issue, there's no more signal issue. The downside, of course, is that typically you're not going to get a very strong bandwidth. You're not going to be able to communicate videos over such a link. It's more like short messages, updates, turn on a switch, turn on the sprinkler, activate a node, measure temperature. Things that take small bandwidth. But the great advantage is that it's pretty easy to work with once you understand the basics. And we have created with NoCan a platform that hides actually all the complexity away from the user. So how does it work in practice? As I said, you have a Pi Master and a CAN 0. The Pi Master is mounted on a Raspberry Pi, and together they need to be powered through with a power source, typically 9 to 24 volts. The nodes communicate with the Pi Master, and the Pi Master can communicate with the nodes. Actually, the nodes can communicate with each other just as well, and you can add 1, 2, 3 more, and you can create, with NoCan, you can create a network of up to 300 meters. So let's say you have a sensor connected to a NoCan network. So the sensor will send information to the node, and the node will send it to the Raspberry Pi. But what does the Raspberry Pi do with that information? Where is the IoT, the internet here? Well, actually, with the NoCan platform, you can then send the data to a mobile phone, for example, thanks to the Blink compatibility. You can send your data to MQTT backend. So this is great for IoT applications. You can also monitor your network with a web browser. NoCan includes a web server. And if you prefer, you can script everything with a command line. List nodes, send message to nodes, collect messages, react. So it's extremely flexible as a platform. You can also upload firmware directly over the network. Obviously, if you're building distributed applications with multiple nodes covering a very large distance or stuck in hard to access places, you don't want to go there with a USB cable and just try to program them or poke them around. So NoCan allows you to upload firmware over the CAN bus network. You can do it from the command line or from the Arduino environment directly. Well, thank you for listening to this little introduction to the NoCan platform. I hope you enjoyed this material. We might make more in the future, actually maybe a video on how CAN bus works. We have also plenty of ideas on microcontrollers and stuff like that, so stay tuned. You might be wondering, why did you call it NoCan? Well, I thought it was funny. I picked the name. Like you have NoSQL, I thought NoCan was kind of, a joke, saying that we're taking CAN bus where no one has taken CAN bus before. Thanks for listening.